Good morning, everyone. Today lecture topic is CPU scheduling algorithm. Basic concepts. Maximum CPU utilization is obtained with multiprogramming. Several processes are kept in memory at one time. Every time a running process has to wait, another process can take over use of the CPU. Scheduling of the CPU is fundamental to operating system design. Process execution consists of a cycle of a CPU time burst and an IO time burst, as shown in the next slide. Processors alternate between these two states evenly. The final CPU burst end with a system request to turn. The CPU scheduler selects from among the processes in memory that are ready to execute and allocate the CPU to one of them. The dispatcher module gives control of the CPU to the process selector by the short time scheduler. This involves switching context, switching to over user mode, and jumping to the proper location in the user to restart the program. Scheduling criteria. Different CPU scheduling algorithms have different properties. The choose of the choice of the particular algorithm may favor one class of process over another. In choosing which algorithm to use, the properties of the various algorithms should be considered. Criteria for comparing CPU scheduling algorithm may include the following: CPU utilization, throughput, response time, waiting time, and turnaround time. First one is CPU utilization. It is the percentage of time that is that the CPU is busy executing the process. Second one is throughput. Throughput is a number of processes that are completed per time unit. Third one is response time. Response time is the amount of time it takes from when a request was submitted until the first response occurs. Next one, waiting time. Waiting time is the amount of time before the process started after first enter the ready queue. Last one is turnaround time. Turnaround time is the time of the amount of time to execute a particular process from the time of submission through the time of completions. Single processor scheduling algorithms. Some of the single processor scheduling algorithms are first come first service, that is FCFS. Second one is shortest job first, SJF. Third one is priority. Last one is round robin. In first one is FCFS scheduling algorithm. With FCFS, the process that requires the CPU first is allotted the CPU first. For the example, given the processors P1, P2, and P3 with the post time 24, 3, and 3. See the Gantt chart. Next, waiting time for P1 is 0 and P2 is 24 and P3 is 27. Average waiting time is 0 plus 24 plus 27 divided by 3, that is 17. Average turnaround time 24 plus 27 plus 30 divided by 3 equal to 27. Next type is SJF scheduling. The SJF scheduling associate with each process the length of its next CPU burst. When the CPU becomes available, it is assigned to the process that has the smallest next CPU burst. Two schemes are available. First one is non-preemptive, second one is preemptive. In this non-preemptive case, once the CPU is given to the process, it cannot be preempted until it completed its CPU burst. Second one is preemptive. In this case, if a new process arrives with the CPU burst length less than the remaining time of the current executing process, preempt. The scheme is known as the shortest remaining time first. Let's see the example for non-preemptive SJF. Consider the process P1, P2, P3, P4 and with the pause time 6, 4, 1 and 5. All are the arrival time is 0. See the Gantt chart. Next one is average waiting time is 0 plus 1 plus 5 plus 10 divided by 4, that is 4. Average turnaround time 1 plus 5 plus 10 plus 16 divided by 4, that is 8 milliseconds. Let's take an example for preemptive SJF. Consider the process P1, P2, P3, P4 with arrival time of 0 milliseconds, 2 milliseconds, 4 milliseconds, and 5 milliseconds with burst time 7, 4, 1, 4. See the Gantt chart. The average waiting time is 3 milliseconds. The average turnaround time is 9.75 milliseconds. Next, third type of priority schedule. Third type is priority scheduling. The SJF algorithm is a special case of the general property algorithm, scheduling algorithm. A priority number is associated with each process. The CPU is allotted to the process with the highest priority. Priority scheduling can be either preemptive or non-preemptive. A preemptive approach will preempt the CPU if the priority of newly arrived process is higher than the priority of the currently running process. A non-preemptive approach will simply put the new process at the head of the ready queue. SJF a priority scheduling algorithm where priority is the predict next CPU burst time. The main problem with the priority scheduling is starvation. That is, low priority process may never execute. A solution is aging. As time progresses, the priority of the process in the ready queue is increased. Last type is round robin scheduling. In the round robin algorithm, each process gets a small unit of CPU time, usually 10 to 100 milliseconds. After this time has elapsed, the process is preempted and added to the end of the ready queue. If there are n processes in the ready queue and the time quantum is q, then each process gets 1 by n of the CPU time in junk at most q time unit are once. No process waits more than n-1 q times units. Performance of the round robin algorithms are q large is FCFS, q small is q must be greater than the context switch time, otherwise the overhead is too high. One rule of thumb is that 80% of the CPU utilized burst should be shorter than the time quantum. Consider this example for RR, that is round robin scheduling with the time quantum equal to 20. Consider the process P1, P2, P3, P4 with burst time 53, 17, 68, 24. The quantum size equal to 20. Let us saw the Gantt chart. Typically higher average turnaround than SJF but better response time. Average waiting time of RR equal to 73 milliseconds and average waiting time is 115.5 milliseconds. Thank you.